Okay, now number 15. Okay, what this is saying, it's really asking you to kind of understand uh, what goes on when you FOIL. Okay, and that's what it's asking you. Hey, Mr. Hole, we're doing.
Get me here. We have a meeting.
No, we're going to do what are we doing? SAT math review. Yeah. So
We are?
Yep. No, we are. You're welcome to join in.
Can't do that stuff.
What's this? AX plus 2 times BX plus 7 is equal to 15x squared plus CX plus 14. Now they want you to find possible values for C, and they also tell you that A plus B has to equal 8. So what do we have? We have a choice of A being their whole numbers. We can have A is 3, B is 5, or we can have A is 5 and B is 3.
They don't have to be home, do they?
Yeah, according to this they do.
Oh.
Yeah, this is for the SATs. So then FOIL this out. FOIL it out and leave your variables there. Give it a try. We're just doing, they have their SATs on Saturday.
Wait, are we plugging the 3 and 5?
No, not yet. Not yet. Not yet. Hmm?
It's 14 on both sides of your fine.
Right.
So they go away.
But we're interested in possible values of C. The question is, what are the two possible values for C?
So your squared, AB times B has to be 50.
Correct. Yeah.
So 3 and 5.
Yep.
So now C is just whatever the sum of 7A plus 2B is.
And remember, A can be either 3 or 5, and B can either be 5 or 3. So solve that equation using both of those, and you come up with two possible values for C. You should have seen your guys up there doing. That's one of them. Yep.
And it's 41.
35 plus 6, 41.
So how did they do on their integration?
Good, except they came across an integration by parts problem, and I gave them the quick and dirty.
Did you show them how to do it the short way?
I started to, yeah.
Oh.
So
I need to go over this stuff with Anna.
So did you come up with two values for C?
See you later.
Oh, see you, Jim. Yep, 31 and 41, and that's exactly the answer. The answer is letter D.
So, Dr. Koch, for those,
Mm-hmm.
do you have to plug in 3 for, like, did you plug in 3 and 5 for, so 3 for 7
3
and 5?
and 5. Then I plugged in 5 and 3.
Okay.
Yep. Because remember,
I don't know.
we don't know which is which.
And I was putting an X in there, but there shouldn't be an X in 7.
No, because we are only interested because 7A plus 2B, that's going to equal your coefficient C. We don't have to, because you have an X there and an X there, and let's look at it this way. Let's factor out that X. X, 7A plus 2B. And there's your C, or that's not over C, but that is your value of C. Think about factoring, too. That's a big deal. Hey, Dana. Okay, pretty good. So when you see something like that, remember, you really have to understand what these terms mean. And if you get those two possibilities, you have to solve for both of them. All right. Next one is really one that will jar your mind a little bit, I hope. You're given the following. 3x minus y is equal to 12. 8x over 2y equals what? Oh, yeah. Oh, that's good. Good. That's the calculator version, and this is the value for no. This is the one for no calculator. We're starting from the back. We're starting from here, moving backward. Okay, so for problems like these, you want to say, can I make that 8 look like something with a 2 in it? 2 to the third, that's 8 raised to the x. Multiply the exponents, you get 2 to the 3x over 2 to the y. And now we use our properties to say, well, that's equal to 2 to the 3x minus y. So what is 3x minus y? 2 to the 12. And that could be anything. You know, if maybe there was a 16 up there for some reason, and they gave you different things to. You know, you basically want to get it in terms of a common base. And once you do that, you take advantage of all your properties of exponents. All right. Are you familiar with these types of exponential properties? All right, great. All right, the next one is just nothing more than an exercise in algebra. You're gonna have this 1 over x plus 2 plus 1 over x plus 3. And they want you to find a version of that that's going to be simplified. Now, when I look at this, you might be tempted to say this is a pretty complicated problem. But I'm just going to focus on the denominator here and trying to add these two. In order to do that, if I want to add these two fractions in the denominator, what do I have to do? Right, so what am I going to multiply this one by? Yeah, x plus 3 over x plus 2 times x plus 3. And this one is going to be what? X plus 2 over x plus 2 times x plus 3. Now, let's look at our answers. Now, first of all, this is still all over 1. Now, let's go ahead and take care of the like terms in the numerator of these fractions in the denominator. You're going to have 1 over, what do you have here? Not x squared, we're adding 2x plus 5. Looking good here. And right away, I'm looking at two things, and you know you're going to have a quadratic down here, right? You know you're going to have a quadratic. So you could immediately eliminate question answers C and D. Okay? Now, let's FOIL out the bottom. X squared plus 5x, plus 6. Now, this is 1 over that. So how do I reciprocate that? Or how do I simplify that? Well, if this is 1 over that, remember it's the same thing as just flipping that over. Right? So that is equal to x squared plus 5x plus 6 over 2x plus 5. Something in the denominator of the denominator of a denominator becomes the numerator. So your answer is going to be B.
So if we have a 1 on the top, we just flip it off.
Once you like if you have something like this, like 1 over A over B,
Then you just
flip and multiply.
Okay.
Yeah. So this, this would be 1 over 1 times B over A.
Okay.
Yeah. It's a good thing to know. All right. Here's a good one. Number 12. Line passes through origin. Okay. Before we go any further in this question, line. Y equals mx plus b. You're going to be thinking that in the back of your mind right away. Line, line, line. And then you're going to think, passes through the origin. What's your b? What's your y-intercept? Yeah. And it says here, has a slope of 1/7. Okay. So what's your m? 1/7, yeah. So my equation is just y is 1/7 x. Now it's a plug and chug. And obviously, if I put 0 in for x, look at our answers. I don't get 7 for y. I would get 0. If I put 1 in for x, I'm not going to get 7. So don't be fooled. Don't get your ordered pairs mixed up. Because if you put a 7 there, and you're going to get a 1 there, and if you mix up on b, if you mix that up, you might get confused. 7 and 7, that's actually not going to work, because if I put a 7 here, it's going to be 1, and 1 does not equal 7. So the only choice that works is 14 for your x value. 14 divided by 7 is 2. So you're going to end up with D as your answer. Your point 14, 2 will satisfy that equation. Is it coming back to you, this stuff? Good. Well, we'll keep working. We'll keep working. Okay, number 11. So anyway, my point in that last one is look for words like passes through the origin, and then you get some information about your y-intercept. Okay, in the equation above, this is a great question. In the equation above, B and C represent the price of beef and chicken. So beef is going to be $2.35 plus 0.25x, where x is according to this, the time in weeks after a certain point. And your chicken price is $1.75 plus 0.4x. So it says B and C represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st. What is the price per pound of beef when it was equal to the price per pound of chicken? How are we going to approach that? Well, if we want to say, you got to solve for x, but don't forget what x is giving you. X is giving you a time. Right? So you're right. And how are we going to solve for x? This is at the point where they're equal. Right? The price of beef at the condition where B is equal to C. They tell you the price per pound of beef when it was equal to the price per pound for chicken. So you set these two equal to each other, then solve for x.
I got
4. Now you know the time. They're asking you about the price of beef. Don't put it in the wrong animal because then you'll get the wrong answer. 335? Yeah, good. So the trick with that is you look for words like when the prices are equal. The only thing you can solve for is the time, and then pick, they say the price of beef. So you want to go back to the beef. Okay. All right. This next one is really good. They're giving you this function, g of x is equal to ax squared plus 24. And they're saying g of 4 is equal to 8. And then they say g of negative 4 is equal to what? So in order for us to evaluate this function, you have some given information. What do you think we need to get first? A, right? So how are we going to get A? We're going to plug A in for our... Well, g of 4 equals 8. So g of 4 is also the same thing as 8, because this is a given condition. It's equal to ax squared plus 24. So yes, yep. So 8 is equal to A times 4 squared, because that's our value for x. So that's 16 plus 24. Okay. So now you don't even have to do any square rooting or anything. You just say, well, something times 16 plus 24 gives you 8. So what does A have to be? Well, obviously, what's that? Negative 1. Yeah. So now we go back up here, write our g of x. That's equal to negative x squared, negative 1x squared, plus 24. So now what they want you to do is evaluate g of negative 4. And right away when you see that, you should be thinking, hey, negative 4 squared is the same as 4 squared. So my answer will be 8. Good. You seen it, Dana? Great, great. Wonderful. Okay. Next one's pretty straightforward. It's just two equations with two unknowns, and they want you to get the solution to these two equations. You have 3x plus 4y equals negative 23. And in my mind, what I'm going to do is I'm going to keep the x first because I like to see them lined up. Because you see in that second equation, they write it as 2y minus x is equal to negative 19. I'm going to write it as minus x plus 2y is equal to negative 19. And I mean, if you want to get rid of the y's first, you can do that. But I'm seeing there's a minus x there. So then I'm just going to say, hey, I'm going to multiply that all by 3, add them up, solve for y, and then go ahead and get my x value once I know y. You don't? All right, let's go through it again slowly. Hang on one second. May have gone a little quickly. You have two equations, and you want to get the solution. So I get 3x plus 4y. That's equal to negative 23. The other equation is 2y minus x is equal to negative 19. Now, I like to keep things lined up. So I'm just going to, this is the way I would do it. We'll do it two different ways. I'm going to rewrite this as negative x plus 2y. That makes your y's lined up in your x's. Is equal to negative 19. So let's erase that. Now, there are one of two ways we can do this. We can multiply this bottom equation by 2 and subtract and get rid of our y's. Because you want to get rid of one of the variables so you can solve for the other one. Then once you know one of them, you're going to be able to get the other. So let's multiply this whole equation by 2. So that's going to be negative 2x plus 4y is equal to negative 23 plus negative 38.
Wait, Dr. Patrick,
Mhm.
we have to multiply by 2.
Not if you're going to subtract these two.
Oh, okay.
Yeah, we're going to subtract them, so you're going to get a negative value for x here. So let's follow it through. Oh, so this was what, negative 19. So now I have to multiply everything by negative 2. So negative 2x plus 4y is negative 38. Here it's going to be 3x plus 4y is going to be negative 23. So I'm going to subtract these. So we get 3x minus a minus 2x is 5x. 4y minus 4y is 0. Right? 0. So negative 23 minus a minus 38. What does that work out to be? Negative 23 plus 38. And that gives me 15. So x in this case would equal 3. And so you can look down here and you say, whoa, let's look at all the x values. Well, A has minus 5, B has 3 for x, 4 and 9, so B is the only one that can work. So you don't even have to go back in this case and solve for your second value of y, or the value for y, if you just look at the choices. And see the only one with an x equals 3 is letter B. Now, if you saw two of them with x is equal to 3, then you'd have to solve for y. Did that explain it any better or not really? The goal is that you want to eliminate one of them and then just solve for the remaining variable.
Why do you have to?
Because the only way, let's go back to this equation. The way the original equation was written was, I wrote it as minus x plus 2y is equal to minus 19. And if you want to eliminate the y's by subtracting, you have to have 4 of them. So 4 minus 4 would be 0.
Oh,
So you multiply everything by 2. So you get negative 2x plus 4y is equal to negative 38. Then you multiply everything through. That gives you, that's going to give you this equation here. And then you're going to subtract. We could have done it like I did it also with x's. You could eliminate the x's first. What's wrong, Jilly?
I just got a text. So my brother went to sleep today
Uh-huh.
for the first time. So I texted him.
Contemplate some things here.
I have to go take them.
That's fine. Go ahead. You have A over B is equal to 2. And they want you to find what is the value of 4b over a? What is that value going to be? All right. Well, what can we say here when we do this type of thing? Well, we can solve for one variable in terms of another. So let's go ahead and let's say if I say a is equal to 2b. No, don't forget we want 4b over a. So if a is equal to 2b, 2b over a is equal to 1, isn't it? Because if that's equal to that, then anything divided by itself is equal to 1. Okay. All right. A over b is equal to 2. That's given in the problem. Okay. So then we're going to go, all right, a is equal to 2b. Now, we want to evaluate this guy up here. So why don't we divide both sides by a? Well, if a is equal to 2b divided by a has to be equal to 1. Because anything divided by itself is 1. Yeah, that's the thing. And so if 2b over a is equal to 1, I want to get 4b over a. I'd multiply both sides by 2. 4b over a is equal to 2. Kind of interesting. Interesting one. Now, number 7 seems like a nightmare of algebra. But it isn't. It isn't. It's actually so extraordinarily simple that you're going to just have a little bit of a laugh. Get this crazy looking function. M is equal to r over 1200 times 1 plus r over 1200 raised to the n power divided by 1 plus r over 1200 raised to the n power minus 1, all this times p. And they want you to say, well, what does p equal? And all you have to remember is I want p by itself. So I multiply both sides by the reciprocal of this really obnoxious looking function. Flip it, multiply over here. That's going to give you p. So p is going to be 1 plus r over 1200 to the n minus 1 divided by this mess, r over 1200 times 1 plus r over 1200 to the n times m. And that should be b. So simple. Looks really nasty. Looks like, oh, do I have to distribute? What do I have to do here? Oh, flip, multiply, boom, done. Okay. Now, number 6. Number 6 is a cute one. I like this one. And again, I'm going to post all these. These are all non-calculator ones. And then if we have time, we can do calculator ones. If not, I can go through and do the calculator ones and make a little video on some of the more important problems on the calculator ones. Okay, here's our little function to represent the height of a boy in inches in terms of the boy's age in years between the ages of 2 and 5. So the height is equal to 3a plus 28.6. And it says here, based on the model, what is the estimated increase in inches of a boy's height each year? Now you have to think about this for a little bit. We want to know essentially what is called the delta H, right? The change in height per year. That's what that delta means. And you don't have to use this notation if you don't want to, but it helps me to think about it. Because I think that means the final height minus the initial height. Now, A is your value in years. So let's just look at 2 consecutive years. Well, my 1 year from now, my H final is going to be 3A plus 1. That's 1 year in the future. Plus 28.6. My initial height is just going to be 3A plus 28.6. What we have to do then is we need to distribute and then subtract the two terms, or the two equations. So when I distribute 3A plus 3 and just take the difference of these two, well, 3A minus 3A is 0. 28.6 minus 28.6 is going to be 0. The only thing left over, the delta H, is 3 inches. And that should be answer A. So don't be afraid to take a leap and say, hey, if time now is A and a year later it's got to be A plus 1. Good. 5 is just combining like terms. Why don't you give it a try? I think you can do that one without much help. The only time you're going to screw up is if you don't remember to distribute signs. I got x squared y minus 3y squared plus 5xy squared minus negative x squared y plus 3xy squared minus 3y squared. And what I do is I look at this right away and I see, can I get rid of anything to make my life easy? I got an xy minus a minus xy. That's not going to get rid of anything. I've got a negative 3y squared minus a minus 3y squared. So those are going to go away. Now I play with what I have left. So I'm going to get xy squared minus a minus. That's a plus. So x squared y rather. 5xy squared minus 3xy squared. That's going to be plus 2xy squared. So hopefully you got that. Yeah, those are pretty straightforward. Okay. Let's take a look here. Number 4. Kathy is a repair technician for a phone company. Each week, she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What do you think the 108 means? Exactly. She starts with 108 phones a week. And as she begins to work day by day, you subtract from that. Looks like she can do, 23 phones a day, so easy one. Number 3, on Saturday afternoon, Armand sent M text messages for 5 hours. Tyrone sent P text messages, each for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? This is a matter of just getting things in the right order, I think. You get C? Yeah. Yeah, that's an easy one. He sends 5 hours, and he sends M messages. That's how many messages he sends, plus 4D. There's the total number of text messages. That's a good one. You like to see ones like that. Okay. And the last one in this section, oh my gosh, it's almost 3 o'clock. This is just a goofy question. So it says x minus 1 over 3 equals k. What's the value of x if k equals 3? Yeah, you're done. Oh, and we skipped the I one. Number 2. Don't be tempted to FOIL this one. So, we got a complex number, 7 plus 3i. Again, plus sign here, negative 8 plus 9i. Nothing to this. 7 plus a minus 8, minus 1, 3 plus 9, and you're done. And that should be 8, letter A. So some of them are so very easy.
I'm really liking this first page.
Yeah, well, they're not too bad. Is that enough for now, you think, or you want to look at some of the calculator problems?
Oh, I didn't realize that next section.
Oh, there are?
Oh, there's
Oh, those are some additional problems. They're good problems, those ones on the back.
But this packet's like good to see though.
Mm-hmm. Now remember this relationship. The sine of an angle theta is equal to cosine of 90 degrees minus theta, or the cosine of pi over 2 minus theta. Cosine of theta is equal to the sine of 90 degrees minus theta, or also the sine of pi over 2 minus theta. So in that number 19 there, you've got, well, if the sine of x is going to be equal to 4/5, then what is the value of the cosine of 90 degrees minus theta? Well, those two have to be equal to each other according to this relationship, so that has to be equal to 4/5. We don't even care. Oh, that should be x. I'm sorry, I'm mixing x's and thetas. So real quick, try number 20 on this back page. Let's try number 20. See what you come up with. Figure out what value of x you can come up with. To root 2x. So a is 5 root 2, so multiply by 2. I get 10 times the root of 2. Square root of 2 is already under the radical, and I want to bring 10 under the radical. So I have to bring 100 under the radical. So when it comes out, it'll come out as a 10. So you'll have 2 times 100, or the square root of 200, which is 10 times the square root of 2. Okay, I hope that helps, and we'll pick up with other stuff some other time.